Got it.
We're in good order, and glad to be back again this morning. Hope all enjoyed the eclipse yesterday. That was pretty spectacular. But in any case, I want to continue what I talked about in the previous lecture, namely emphasizing the effect that protein has had on our thinking and human health in rather unusual ways, provocative ways, if you will. And I want to then shift. And first, I'm going to talk a little bit more about the protein question and then shift into the main point that I want to make in this lecture, having to do with the fact that nutrients in food, there's unlimited numbers of nutrients in food, of course, right kind of food. They would tend to work together. They don't work all alone doing things like that, not faithfully at least. So, okay, now let me close the pictures here. Okay. So I'll start out with this the summary, if you will, that I call holistic nutrition. I mean, nutrition has not been taught ever in medical schools, quite frankly, and is usually taught in regards to one nutrient at a time at most. And so I, in my career, which started back in the late 1950s, brought me to this point here where it was very clear to me that nutrients work together. Multiple nutrients, each nutrient having multiple mechanisms of action, we call it, affecting multiple diseases and multiple health improvements. It turns out, I mean, that's a very holistic concept, if you will, as opposed to a reductionist concept where we look at one thing at a time. And so my sort of summary statement is to use a diet that's whole food, plant-based. And the plant-based idea comes from the discovery that animal protein is not what we think it is. We have no need for that. We have no need for the animal protein whatsoever. It only causes us harm. Then I want to turn your attention to the concept of using whole foods, not individual nutrients. So to continue on with what I spoke about yesterday, we have, as I said, focused primarily on protein from animals sources, and animal food or animal protein is considered to be high quality compared to plant food. It was discovered way back in the middle 1800s. So the animal protein tends to have a stronger effect on an increasing body weight of, let's say, experimental animals and livestock, if you will. Means basically more profit for animal production. And from that, we sort of somehow got into this idea that animal protein was more valuable to us than plant protein, which is not true, but nonetheless, in 1924, exactly 100 years ago, a colleague that I knew of at the time when I was in graduate school came up with this idea of determining so-called biological value. That's, as the term indicates, animal protein has higher biological value. It's very puzzling. What it really means technically, according to the way he stated 100 years ago, it means that when we consume, let's say, two different kinds of protein, animal protein, plant protein, a higher proportion of the animal protein is retained in the body. That's all it is. Well, that doesn't prove anything, really. It just says more being retained. If it's more being retained of the wrong thing, that's not a very good idea, to be honest about it. So animal proteins have higher retention, higher quality. Plant proteins really are kind of superficial, to say the least, sort of analysis of the question. Well, it turns out that idea of animal protein being the protein, more important than plant protein, that's stuck with it sort of subliminally. We just sort of assume it. People not in science and not early in health and so forth, they just sort of assume that's where you get your protein from. You have to have animal food in order to get that. So it's not true. And so here's a summary of what happens when we retain more protein, as we did in our own studies, and I'm trying to hear most of this is from our own research, my own lab. We retain more, and so it increases, when we retain more, it increases the production of growth hormone, which in turn is related to faster cancer growth, for one thing. It increases blood estrogen, the female hormone, if you will, which is the breast cancer connection, if you will, and other sorts of things. It increases the free radicals. A higher proportion are being retained, increase in production of free radicals, which are agents, kind of very reactive chemicals that actually spur cancer growth. And then it also increases the formation of cancer mutations, which in turn leads to cancer and decreases natural killer cells, and DNA repair. All those things there really put a clamp on the idea that animal protein is somehow higher quality. It is not. That whole idea of retaining more is only retaining more to do more damage. At the same time, animal protein increases the circulating level of total and LDL, the bad cholesterol in our bloods, which in turn is associated with increased heart disease. By the way, cholesterol does not cause heart disease. It's consuming animal protein that does. But in any case, so heart disease comes out from more retention, if you will. It increases blood sugar and the A1C, which is an indicator, a technical indicator for diabetes risk. So there you have it. You eat more animal protein. And this is just a very brief thumbnail sketch of the kind of things that animal protein does. It increases cancer, heart disease, diabetes, which frankly there's not much left. So the animal protein is really a key significant metric in this whole discussion of protein. We want animal protein, and that's really what has driven us. And we use it as a defense to consume more animal food because we need that protein. It's not really true. Now, I want to share with you something that happened about a little over 10 years ago now at the National Academy of Science, the Institute of Medicine of the National Academy of Science, that determines what level of nutrients we should be consuming, all kinds of nutrients. That started way back in 1945, actually. And so we, in the case of protein, there was a certain amount of protein recommended, and I'm going to show that here. And then I'm going to show you too how much protein we actually consumed. This is pretty significant. And this is a statement that, as I say, is based on going back, to the original recommendations of protein intake. Here I'm showing you the range of protein intake in terms of percent of total calories. In other words, protein fed at 5 to 6% of the total calories in the diet. That's one thing. That's a minimum intake. And then there's a certain amount, around 9 to 10% is recommended, and so forth. Let me show you a little more detail of that. The minimum intake required is 5 to 6%. The recommended dietary allowance, that's 2.5 standard deviations above the minimum requirement. But in any case, this ensures that we all are getting enough protein. Getting around 9, 10% or so is all we really need, recommended dietary allowance. But in reality, what we've done over the years, because of our reverence, without even knowing it, because of our reverence for protein, especially animal protein, we tend to consume as much as we can get, which determines, the dietary patterns. So that black line there basically shows us the range of protein intake in the average population in the United States. So it ranges from a low around 11% or so, up to some little more than 22% in that area. That's the range. So we get plenty of protein, by the way. And 75 to 80% of that protein that we consume on average is from animal food. So in a Western diet, in the American diet, for example, we consume plenty of protein, more than we need, and 75 to 80% of the animal base, primarily because we have this idea that animal foods is the best source of protein and the highest quality protein and all that sort of thing. So it turns out, and this is based on what I showed yesterday from all those charts, when you compare protein intake in different countries as it relates to heart disease, and I showed you a little clip up in the upper left-hand corner, that for all these different diseases, as we compare a bunch of different countries, as the protein increases, the animal protein increases, it increases the rate of heart disease and cancer and all sorts of things. And so that increase associated with the amount of protein consumed is a dotted line here. In other words, when we're at 11%, if we're using only plant food, everything's fine. We can consume up to 15, 20% from plant food if we can get that high. And everything is fine. But actually, we start putting in animal protein because that's, as I say, is what we subliminally sort of think is important. So associated with that, from this chart, from all these charts I showed yesterday, what we see is that as protein goes up in this range here that we're consuming, the risk of a number of different chronic diseases, heart disease, all kinds of cancers, as I said, diabetes, et cetera, it sort of goes up here. So consuming in this range here is the reason why, especially if we're consuming up in this territory up here in the upper ranges, that's when you start suffering high risk of those diseases. Now, whole plant-based diets, whole foods, plant-based, if you will, that provides all the protein we need. If we can have as much as we like, as I say, up to 15, 20% or so, no problems. We don't see that kind of line occurring. It only occurs with animal protein. So what happened, as I say, now about 15 years ago or so, with the National Academy of Science, who determines how much we should consume. Lo and behold, what they did, and quite frankly, they did it dishonestly, beneath the table. I'm writing a new book to tell that story. But in any case, they decided that we should know what's the upper safe limit for all the different nutrients. And they came up with this number here at 35%. They're telling us and telling the public, as now part of our general conversation in this community of nutrition and dietetics and so forth, we can consume protein up to a level of 35% and it's safe. Well, I wanted to take a look at that 35% and compare it with what we see now, just way in the neighborhood of just 11 to 22% protein, especially if it contains it's made of animal protein. So this 35% figure is just total nonsense. It was done rather quietly and behind the scenes. The public didn't get to know this. And it's just basically a technique to sort of emphasize to everybody they need to get as much protein as they can. And there's no problem. That's simply not true. I call it the mob power. I'm sort of adding a little bit here that is because of my new book. But in any case, my question is this. If 10% protein is all we needed, and that's provided by a whole food plant-based diet, why in the world are we saying that 35% is safe? This is absolute nonsense. I think it's one of the biggest, almost criminal-like behaviors that's occurred in the nutrition field for more than the last century. Now let me bring it back to what I showed yesterday. When we started in our studies, first noticing in the experimental animal studies that casein, the main protein in cow's milk, that's high quality, if you will. As we increase casein in the diet, animal protein in the diet, we could turn on cancer like you wouldn't believe, almost immediately, 100% in the way it went. So then we looked at the mechanism to account for that effect. And so what we found here, just quickly, this is sort of representation of the course of cancer development. 3 stages. Starts out initiation. That's when mutations form, and then we go through a period over the next, let's say, months, years, whatever. And our cells are dividing, becoming cancerous, and that's called promotion. And eventually, then it metastasizes. That's called progression. But in any case, what we found when we started looking for the mechanism, how does this animal protein increase cancer? We found all these mechanisms. First, we looked here in the first stage, and here's a bunch of mechanisms here. And then we looked in the second stage, and all of them, after some 15 years or so, with my graduate students, each doing sort of a part of this story. And I didn't know all we were doing at the time was I was looking for the mechanism to account for this animal protein effect, this harmful effect. And that, in theory, would lead to the possibility we could intervene with a drug if we could just make a drug and just still eat the same food. Well, in any case, I'm going over some stuff here from yesterday, but what we found is 8 mechanisms of those 10 increase activity, 2 decrease, but in reality, all these 10 mechanisms increase cancer in unison. So I couldn't get to a point of determining which mechanism really mattered, so we could make a drug, which was not the point. So here I'm showing in here just a schematic representation of what I just told you. Here we have a normal cell, picture a normal cell here. Here's a cancer cell. A normal cell divides into a cancer cell sometimes. So the carcinogen that starts it off, causing mutation, it comes into the cell, and that's one of those mechanisms. Animal protein increases the rate at which the carcinogen comes into the cell, and then it's subjected to a reaction catalyzed by an enzyme called mixed function oxidase. And in that process, that enzyme actually gets rid of nasty chemicals that we might from time to time consume. It gets rid of them and detoxifies them, but a tiny little bit, just a far less than 1/10 of 1%, kind of slip out and then are reactive intermediates, and they bind to DNA and it damages the gene. And then that gene, if it's not repaired, we got mechanisms to repair that kind of thing. If it's not repaired, then and that cell divides, if this normal cell divides, it becomes cancerous. And there's the cancer cells with the mutated DNA. At that point in time, now we got the gene for cancer in this new cell. And it goes through a whole series of very complex steps, and it eventually becomes diagnosed as cancer. And so now I want to show you all those mechanisms I talked about yesterday to make a point. See this little star here on the left? The animal protein increases the amount that's in the cell, and then it increases the activity of this enzyme, increases the synthesis of the enzyme, so more of the damaged DNA is formed, but most of it is detoxified, but nonetheless it leads to that. And then the high protein diet changed the characteristics, the shape of the enzyme in such a way it increases activity. These are the 10 mechanisms. And then the high protein diet increased the amount of carcinogen bind to the DNA. And then, lo and behold, as I said yesterday, the high animal protein diet blocks this really good thing. And then it does a bunch more things, as you can see. So, and then one more good thing it has, it blocks that too. So all these mechanisms are operating together. It's a really important point. They don't operate just one thing at a time, not one mechanism doing one thing. When a nutrient like animal protein is consumed, and other nutrients do this too, when they're consumed, they just sort of splinter up and do their bad things if that's what we're consuming the wrong thing. So now I want to show you one other element here too that's beyond the pale in a sense. I published on this in 1980, summarizing this, and basically it really has to do with the testing of chemical carcinogens. The testing of chemicals for carcinogens. I'm getting feedback here on the voice, but anyhow, in any case, back in the 60s and 70s, there was developed a experimental animal testing procedure to determine which chemicals in an environment could cause cancer, which ones don't. And see this little schematic here of doing this here. The experimental animal studies, the amount of the test chemical is increased up to a fairly high level, far higher than what we humans might get exposed to. And it's simply a test to see whether or not it causes cancer. And that's measured here percent cancer. So that's the kind of study that is done, as you can see here. There's a break in the line here in each case because it'd just be stretched out too far. But in any case, so we do a study and we find out in this test chemical that lo and behold, when you give it at really high levels, it causes a response and increased cancer risk. And if if we have 3 different test groups, maybe 4, if they kind of line up that way, then we draw a line down through to see where that comes with respect to human. This is a human exposure. So this is done very conservatively. We want to make sure that when we're testing these chemicals, maybe coal tar or what have you, we want to make sure that what we learn up here can be extrapolated down to here. And then there's all the calculations are done to make sure that any chemicals that we're exposed to in the environment, we call them environmental chemicals, that any exposure we get to it, it has to be, in theory, below a certain level, below a level that theoretically would cause 1 death per million people. And so this has been a really big deal has led the public to believe that we get cancer from the chemicals in our environment. It's really not true. Some of them, which are mutagenic, may in fact, as I showed in the previous slides, go on to form mutations, of course, but we're talking here about levels far, far, far higher than what we ever exposed in the first place. So we know what that level is, and then we make our determinations whether such and such a chemical cause cancer. You know, like a chemical used on cranberries way back in the 50s that caused a big stir, or apples were being sprayed with a certain chemical that turned out to be carcinogenic, according to this kind of test. So here we are, we humans are right about there. And these chemicals that are said to be carcinogenic are very potent, of course, but we don't usually get exposed to enough to really cause a problem. Here's what I want to show you. This is something you've never heard before, I think. It turns out that our data from casein that we turned on cancer is up here. In other words, casein is far, far more carcinogenic than those chemicals. Can you imagine that? Cow's milk protein or other animal-based proteins, in theory, according to this kind of scheme, are far more able to cause cancer than the chemicals we worry about in our environment. Now, I don't want to make an excuse for those chemicals in our environment. Most of them are nasty. They can do this, that, and everything else. They should possibly in the short run, but they're not the main cause of cancer. The reason that the whole conversation went that way, that those chemicals are the principal cause of cancer, is because no one wanted to talk about the possibility that food itself, something like milk, casein in milk, were far more significant in terms of causing cancer than environmental chemicals that we're being exposed to. It's really kind of an interesting sort of sidekick there. I really got immersed in this myself because we have two laboratories in the United States that sort of determine this kind of thing, one run by the FDA, the other by NIH. And I visited both, I lectured to both at the time. And then there's a third one, the International Agency for Research on Cancer. It's a World Health Organization thing in Lyon, France, and I lectured there as well. So I really got up to my eyeballs in this whole area, trying to point out that the whole program that they were telling the public, which chemicals cause cancer and which ones don't, is kind of at odds with the reality. So anyhow, I said enough about protein, I think, and I've really come to believe that historically, no nutrient has influenced our dietary choice over time than animal-based protein. I call it the driver nutrient. It's mostly subliminal. We don't even really realize we don't know what we don't know, and everybody just sort of thinks this is the justification for eating animal foods, mainly, and that is to make sure we get enough protein. It's simply false. We don't need that. It only causes problems. And people will go around and maybe and get to the point of questioning that, have had their careers destroyed in many ways. I'm one of them that I unfortunately stuck to, but it's been problematic to even question this kind of practice that we have in the American public. And I wanted to show here my own background. And I bring this up here not to talk about myself, but to simply say that the reason I got into this field was actually through science, as I showed yesterday. Science is done a certain way. You have to work with your biases. My biases were from the farm. That's me on a combine there, and my brothers, my dad, and my mother, and so forth. And we were milking cows, and it was all about, making more protein eventually, especially when I went off to graduate school and did a thesis to show how important animal protein was. Enough said. I want to now get to the point was, why is it that animal protein, other nutrients too, but we did this rather thoroughly. Why is it that when that nutrient, in this case animal protein, when it's fed, it doesn't cause just one thing? It causes a whole, we looked at 10, probably 15 I could list there. And every time we looked for a mechanism, we found one. This was amazing because it turned out that when all these mechanisms are all working together, all in the same direction, no exceptions. It was pretty amazing. So I now want to bring you back to trying to elaborate on that point a little bit more. And it has to do with all the reactions that occur in our cells. This is biochemistry. This is basically what I taught myself. for many years. First off, let me explain what I mean by this here. This is the simplest version of all. It's a million times more complicated now, but in any case, these reactions are available in all of our cells of our body, and we got like 30 some trillion cells, to be honest about it, all doing their thing. So in plants, these reactions all exist too. Plants actually capture the sun's energy. We don't. We animals, humans and non-humans, we don't get the energy from the sun to create this series of reactions. Only plants do. So the plants are sitting there, and there's a process called photosynthesis, as you may know. The plants are there, and they capture the solar energy and convert it into making chemicals. And the energy is stored in the bonds that put the atoms together and first forming some sugars like glucose and fructose and so forth. And so the plants, their business is to capture the energy from the sun. And then we in turn then eat the plants to get the energy. That's the way it works. So plants have their role. Obviously, we wouldn't be here if it weren't for plants capturing the energy. So we got all of our energy from that, really. That's where we should get it from. We don't need to eat animals because animals don't capture energy. They sort of store it in their system, of course, but nonetheless, here's all these reactions here. And it's very intricate. And in the beginning, way back when I was teaching biochemistry, beginning biochemistry, we were looking at one reaction at a time and getting all excited about it and so forth. These reactions here, in the top part, it's referred to as glycolysis. Once these first substrates are formed and chemicals, they store the energy there. Then those chemicals are consumed and are broken down one at a time all the way through here. And finally down here, what it does, the enzyme, the chemicals kind of break down step by step, releasing their energy for our use, be what it may, whether it's physical activity or all the millions of other things that our body needs energy for. So that's a very simplistic version of it. It sounds pretty complicated, but it's really quite simple. In due course, yes, so all these reactions then are sort of happen one at a time to give the energy to the body or cells in the various ways. This is what it became not too long after that. That simple reaction, which is this part right in here, actually exploded. And now it's 1,000 times more complicated. There are so many reactions that really, quite frankly, don't act one at a time. That's crazy. But nonetheless, we tend to assume that the public is sort of told that in a sense, that if we can just identify which mechanism does what, then we can make a drug. And that's, in fact, the feature of drug pharmacology. Focus on one reaction, and hopefully that one reaction, if we can make a chemical to stop it, if it's a reaction we don't want to have, being so active, we can make a drug and block it. But it turns out that when we do that, this is the whole drug protocol, I call it. This is the basis for the entire drug industry. They assume that one thing can cause one thing, but on a grand scale, simply not true. They do have their effects for sure. And they can have multiple side effects too at the same time, but they're rather unpredictable. That's why all drugs have side effects. All drugs have side effects. In fact, it's the third leading cause of death in this country. So we have got this very strange idea that erupted quite a number of years ago. I call it reductionism, where we focus on trying to find one reaction that explains one disease, and then we can make one chemical, one drug, if you will, to maybe block it or reverse it. That's our system. And that is the medical system that focuses on that idea. I argue that this is simply wrong. It's very misleading. In contrast, the food protocol, when we do it that way, got multiple nutrients. Each nutrient have multiple mechanisms, no side effects, and it covers the whole thing. When you eat the right food, it organizes all this. And that's what we got from our research, looking for mechanisms. It turns out we eat the right food, vegetables and fruits and grains, obviously, and you mix and match them the way you want. And nature takes over and runs the show. We don't need to just rely on the formation of these drugs to help us out. And basically, it causes us problems. Not to say that some drugs on occasion in the short term, it may have an effect, like in taking aspirin to reduce headaches or something like that. So I'm not totally whitewashing the entire pharmaceutical industry. I'm just simply saying that like 99.9% of them are not needed. We can take care of our health through food and eating the right kind of food, and we don't need to turn around and then rely on uh, drugs to try to fix up to everything going wrong because we eat the wrong food. So anyhow, here's another scheme I just showed you before. It's a little simplified version here of all those reactions coming down here. That's where the solar energy comes down through here, and these chemicals, and they all break apart and release the energy someplace in the body. Here's an example of what I was just talking about. Namely, they came about during the last 100 years, essentially, that there was a relationship between serum cholesterol, that's blood cholesterol, and heart disease. There was a relationship. Cholesterol goes up and heart disease risk goes up. And so they assumed that cholesterol causes heart disease. It's not true. They assumed in particular that cholesterol only present in animal foods cause heart disease. Yes, only present in animal foods, but that's not the cause of heart disease. There's not the, so that was a mistake. And one of the reasons that idea erupted or it came into view was that if we could, if high cholesterol is related to a higher risk for heart disease. And so as I say, they assume that cholesterol causes heart disease. It's really not true, but that stuck with us all that time. And so the idea came up that, well, if we could find that one reaction, as I just showed you, just that one reaction that leads to cholesterol, well, we can make a drug and block it, and then we reduce heart disease. Very simple, very simple. And so here I'm showing here the scheme. This is all these reactions come down to a compound called acetyl-CoA. In any case, that chemical right there, normally is operating in the cells, releasing energy and doing all the good things. But as a sidebar, it kind of sprays off and it goes through a series of reactions to give cholesterol. So the thought was, geez, if cholesterol is associated with heart disease, it doesn't mean it causes it, but it's associated with it. They said, if we can make a drug and block this, we can block heart disease. This happened and was introduced in 1988. It really had quite an effect on me. But in any case, my research, that then came out with a lot of fanfare that we can now, and they were able to synthesize a drug to block it going from here to here, and therefore decrease cholesterol, supposedly decrease heart disease. And so they found a place in one of these reactions here to block it. And they made a chemical to block the formation of cholesterol. These are called statins. Now the number one drug in the world, statin, billions of dollars a year. All allegedly, we take the statins, especially when you get older, and we supposedly have a risk of heart disease. We take the statins so we don't get heart disease. All they're doing is decreasing cholesterol. And if one looks at the data on the effect of statins to affect heart disease, it's a very minimal, almost non-existent effect. Nothing like what diet can do. And I'm referring in particular to the reversal of heart disease. My good friend, Dr. Caldwell Esselstyn, and Dr. Dean Ornish. They didn't go to this kind of rationale here, but nonetheless, they were able to show, especially Esselstyn, to show that heart disease can be reversed just by changing diet. Let nature do its work. And so just eating the right food, plant-based diet, will then block heart disease, and it has nothing to do with trying to stop the production of cholesterol. Cholesterol in the blood does go down quite dramatically when we start consuming plant-based diets. And that's associated with a lower risk of heart disease for sure, even reverses heart disease, as you know. But statins is not the way to go. The way to go is just simply using food, which has no side effects. Statins have side effects like all drugs do. So the whole food plant-based diet controls cholesterol, thus it controls heart disease with no side effects. That's simple. This is the business of the entire drug industry. Just an example. It's a number one example I'd like to point out. Of course, now they've invented thousands of drugs because it makes money. Now, allegedly, each one doing their thing that we might think is a good thing. And as I say, in the short run, some of these drugs might work a little bit for the short run, but the fact that we're feeling like we have to use the drug means we're not eating right in the first place. We're doing something else wrong. When in reality, we don't. We don't need drugs. I don't take drugs. I'm 90 now. That we didn't go down that road. Okay, let me show you a little bit more about this whole idea of focusing on one thing at a time. This is pretty dramatic. This is back in the 1980s. And there was an idea that beta carotene, which is basically is the stuff in plants that gives rise, it's vitamin A. This is vitamin A that gives rise to what's called vitamin A. The beta carotene is an antioxidant. It's consumed from plants. And when it gets in the body, it actually forms a metabolite called retinol, if you will. But anyhow, beta carotene was kind of the rage back in the 80s because it's an antioxidant, and they were just discovering, this is really important. And so there was a study that was done, and one of the reasons everybody got excited about it, because it was a study done with smokers. Smokers get lung cancer, we know that. Lung cancer coming from smoking is largely an excessive oxidation going on in the body. So this beta carotene is an antioxidant. So it sounded like a good thing. So they did the study. This is a three-dimensional chart, as you can see. Along this axis here is the amount of smoking. They're comparing people, non-smokers, with people who consume smoking for up to 30 years, compared with those smoking for more than 30 years. And along this here, the line, this axis here, is the amount of carotene they were consuming. Okay? And so the lung cancer is occurring, especially amongst those smoking cigarettes for more than 30 years. And it seems to go up in a stepwise fashion, as you can see there. It turned out that it was just, this is a breakdown here. Something was happening amongst these people here that's different than these people. Just there's a perfect dose response relationship. It turns out that if we look on this axis here, we see what it is. It's a carotene consumption, because it was kind of, mentally it was sort of considered a really good thing that maybe we should use in form of a supplement, possibly. They measured the amount of carotene being consumed in international units per day. And the ones consuming the least beta carotene, the least of this antioxidant, which is good for preventing lung cancer, they're the ones who got the most cancer. And as they increase the amount of beta carotene that's being consumed from that up to here, it got to a point where that they could actually, looking at these smokers, the ones who got the least cancer, almost no cancer, were the ones consuming the most beta carotene. That was exciting. A lot of news on that at the time. The beta carotene can be used. Maybe we can put it in a pill and so forth and block lung cancer from forming. So they did a study. They said beta carotene, that's really important. That really looks great. I was actually invited to be on that committee at the time. I had other things to do, but so I was close to these studies at the time. It was organized at Harvard, actually. And so we see higher beta carotene consumption, lower breast or lower lung cancer. So they organized a study to check beta carotene. They put beta carotene in a pill. Then what the idea was is this, and back in the days, we didn't have nutrient supplements really. And this was the first nutrient supplement being considered at that time as the birth of a new industry, if you will. So they organized the studies, a joint study between Norway and the United States. They had 29,000 male smokers in the study. And so the one group took beta carotene, the other did not, just to see how much effect the beta carotene could have. And they followed them up. They were intended to follow them up for 8 years, but had to stop the study. I'll show you in a moment why they just had to stop the study. Beta carotene, remember, is a very good, we think, a very good antioxidant. It's good when it's in plants, no problem there. It turns out that people consuming, in this study, the smokers who were consuming beta carotene in the form of food, just eating the right kind of food, more plants, if you will, it decreased within 5 years. They didn't have to wait to 8 years to see the effect. They saw it already in 5 years, which is pretty remarkable. It turns out that the people consuming beta carotene in food, their risk of getting lung cancer was decreased by almost 20%, and statistically significant. That's what that little story means right there. Just in that period of time. So beta carotene was working, as the other studies showed, more beta carotene, less lung cancer. Then they looked at people taking a supplement, and they should really work here. It did the opposite. The beta carotene, when it was put in a pill, actually increased lung cancer, and it was significant. This caused a furor. I have to tell you, broke out into the news and probably in a sense, but certainly in the scientific community, and FDA and everywhere, and then in various agencies, they were accusing people of doing things. Well, it turns out this demonstrated a principle. And the principle was that we can have a nutrient in food, and it does a good thing. They have oxidants and different complex carbohydrates and so forth. They do good things when they're working all together. But when they take a nutrient out of the food and put it in a pill, all bets are off. It might have the opposite effect. In case in the short run, you might see a good effect, but in the long run, we don't get nutrients out of nutrient supplements, period. That's not the way to go, because now it's becoming a multi-billion-dollar industry, as you know, and I was actually involved in that myself in a court hearings when they were trying to get the government to change that whole activity. People want to believe that they can get their health and get their nutrition simply by taking nutrient supplements. It's not true. They should eat the right food. That's where things happen. Nutrient supplements really don't do anything in terms of, and they may in fact cause harm, as you can see here. So let me just extend this argument then, or this presentation to something a little bit different. Here's a quick summary. Nutrition, before I go on, nutrition is, I call it the biological expression of whole plant foods. For me now, after all these years, there's no question about it. Whole plant foods is where that we get our health from. It's not from animal foods. It's not from nutritional supplements. And so these whole plant foods basically are all working together. We can sum it up as one way to think about it, but that's not really very, very good way. It turns out when we consume whole food and they're all consumed at the same time, Mother Nature takes over. These nutrients do not work alone. They can do that, but that's not where the good effects are. They work in unison, as I showed from the studies that we did in the rat studies. That when they're working together, we see dramatic effects. You can see it in no short time. So in reality, when we're eating food, all the nutrients, the millions, trillions of different nutrients, if you will, reactions that are going on, they work as a symphony as a whole. So basically it says to it, eat the right food and destroy it. We don't, and keep ourselves healthy. When we assume that the nutrients are working alone, as we do in nutrient supplements, we get a lot of confusion. And unfortunately today, there are people in this business, in the plant-based community, who are talking about all kinds of individual facts, doing this, that, and everything else. That's really not the way, nutrition works. And it causes a lot of confusion, and and as I say, they tend not to work quite that way. So eating food, nutrients working in unison, there's a way to create health, actually. And by the way, when we try to work with nutrients working alone, it eventually leads to our making chemicals look like nutrients or something like that. We call them drugs. Causes lots of confusion. And as long as we get intellectual property protection through the use of patents, we get a profit out of it. So we got two arms here working. This is the arm here that makes drugs and supposedly keeping us healthy, but in reality, it's just making a lot of money for people. We as individuals don't need that sort of stuff. We work here, it's a nice, safe way to go. This is here with a lot of side effects. And so that's the difference between food and drugs. Food is what Mother Nature does, and that's the way we should work. And unfortunately, I don't have time here to take about 10 to 20 lectures, but in any case, talking about how nutrients work together in food is really really incredible observation. That's what leads to health. When we do the wrong thing, eat the wrong food, And then we get sick, and then we want to fix ourselves with drugs, have working alone, and it just causes a lot of problems. So really a distinction. And of course, the kind of diet we should be consuming is without animal protein. We don't need animal foods whatsoever. There's nothing, no gain in it whatsoever. And we should be eating plant foods along with the antioxidants and fibers and minerals and so-called vitamins. Aristotle, by the way, sort of knew this. He didn't know these details, but back in ancient Greece, 400 BC, he knew enough about this concept of health for sure. He made a very famous statement that said the whole is greater than the sum of its parts. And this is exactly what I'm saying in the research that I've been involved in. The whole all works together in marvelous ways, and we can't tease apart things to see what they do and then expect to get the results we like to see. We should turn our interests, in this case here, over to whole plants, basically, and then it does that work. And by the way, here's a quick summary of the difference between plants and animals in terms of what they actually contain. Antioxidants are all made by plants, only made in plants. Complex carbohydrates, really good stuff, made in plants. And so-called vitamins, these are all in plants. And in plants, they tend to be rather lower, not altogether, but for the most part, they're lower in total fat and, of course, protein, 9 to 11%, if you will. Animals, they don't make the stuff that really matters. And we don't make antioxidants and complex carbohydrates. We don't do that. There's almost none. But we usually, when we're eating our other fellow animals, we're eating a lot of fat to go with it. And so that's why the plants work. A diet containing plants work dramatically. And I showed you in the last lecture the how much increase in heart disease, cancers, and so forth occur by eating on this side of the equation here. It's huge. It's just no comparison. Processed foods, incidentally, is another category. As I mentioned here, it's a kind of a mixed bag. It's a bunch of stuff that we can take plant parts and put them together and put a lot of salt, sugar, and fat in them. It's likely going to lead to something worse. So that's why I say whole. The whole foods itself work, but processed foods, we take them apart, mix and match them, so they taste good and we get addicted to it, and so that's another problem. One more point I'd like to point out too is that this story about nutrition and what we should eat and what shouldn't eat is so huge because it turns out that we have big problems. And I've just grouped here two groups of problems that we kind of have to live with that we talk about a lot about. And I grouped them into environmental problems and into human health problems. Environmental problems, we got deforestation problems and deep water loss, subterranean water under our soils and stuff, climate warming. I mean, each of these things can be considered a separate topic, essentially, caused by something. And each of them have their own cause, if you will. We tend to think that way. Each one of these has its own causes. And so they have, and on the human side, look, here's some of the problems we have. We have the highest healthcare costs in the world. We have lots of drug side effects, the third leading cause of death in this country. We have short life, the shortest life going. We use prescription drugs. We depend on prescription drugs, especially in our older age. High disease mortality, I showed those kind of charts here. And of course, it ultimately leads to unequal health services, depending on what kind of funding people have to pay for their illnesses. So we tend to think this way. This is what's wrong with our brains, I guess. It's pretty natural, to think we see something going wrong, and then we try to find out exactly what's wrong with it, and we're going to fix it. So we spend all of our time, let's say, working. Some people spend a lifetime working on soil loss, what have you. We make that presumption. Here's what I question. Do these all have their independent causes? Yes, they do. They all have their independent causes in many ways, and we can work on each of these to solve them. But in reality, this is what matters. There's one comprehensive cause for all these things. It's really quite dramatic, and I wish I had a few more hours to show the data for this. But if we eat the right food, we don't get heart disease, really. We don't get cancer. We don't get a lot of the diseases that kill us and shorten our lives. in different kinds of ways. And it turns out that what we're doing wrong is eating animal products primarily. We're also using mix and matching foods and making as I say, the processed foods too. But it's the animal food uh, environment that we live in. We deforest the forest in Latin America, especially to grow cattle. They use a lot of water. We suck a lot of the water out of this naturally in the ground. It's really going down. It's scary. Climate warming, all this stuff, these things here come from basically tie the original source of these problems coming from eating the wrong food, period. We're eating basically on an animal food side. And it's the same thing over here. That one comprehensive cause, if we eat whole food plant-based diets, these problems here tend to resolve themselves, as do these over here. I mean, to me, I mean, we got the data on this. It's so impressive. It's so spectacular. And people don't tend to know this, that if they just ate the right food, then they're healthy. They don't need drugs. Their healthcare costs go down. They don't need to buy drugs or depend on drugs and buy them. And we can have a longer life. And by the way, I'm talking about a life of an extra 20, 30 years, which we should have. But unfortunately, a lot of people in this country, most of us, are eating more and more on the wrong end of the scale for food. And so we have a high disease mortality. I could just say a little side story in this. I got so caught up in this over my last almost 70 years of doing this research. And it was a little bit late when we got around to changing our diet, but my wife and I did. I was in my early 50s. She was in her late 40s. We changed pretty much at that time. And I hate to not, you should knock on wood when I say this, but I'm 90 right now. She's 83, and we don't use drugs. And we're getting the kind of disease and the kind of health that we had hoped to get. And both our families had passed away at many years before this. There were high cancer on her side and heart disease on our side. But in any case, I'm really convinced of this. Sorry for my enthusiasm, because a lot of people might want to do otherwise. But all I'm saying is that the science, if we get in there and really ask the question about the science and understand what's really going on, then this becomes just abundantly clear. One last thing I want to say, and this is, for me, really critical. Those of us in universities have the responsibility of looking at research. Those of us who do research, I should say, have a responsibility of doing research in an honest and transparent way as possible. We usually get our funding from the government, and taxpayers, if you will, and we had the freedom to investigate questions, whichever way it went. In my case, it went the opposite way of what I originally thought. I was into the animal protein thing and all that, and learned, in fact, it was exactly the opposite. But I had the freedom to say what I wanted to say when I wanted to say without being fired. And so finally, and that was all great. And science was a fantastic, a lot of fun with students and so forth. I really enjoyed it immensely. But I had gotten academic freedom very young, and at the time in my early 30s. And so I felt kind of a little bit cocky to go forward and to do what I felt like doing without, worrying about getting fired. Well, it turned out in 1980, there was a study done in 1980, from 1980 until 2010, done by an organization, American Association of University Professors. They did a survey on a question concerning academic freedom. It turned out academic freedom, that's faculty have tenured positions that you can't be fired. And there's a reason for that, because then they have the freedom to look at things honestly. They don't have to depend on their bosses, if you will, as to what they should do. Anyhow, academic freedom declined from 1975 to 2011, straight down. It was really quite. And now at the most we only have 9% of us left, probably more like 5% are still tenured. And unfortunately, the whole institution of academia, which had a responsibility, among other things, is to teach students honestly, but also to do research honestly, that's been taken away. And by as I say, about 10 years ago. It turns out as that went down, as academic freedom went down, where we had the freedom to speak and exercise our First Amendment rights, as that went down, and right along with it, the percent of funding that was coming from the public sector to the private sector to industry went up. That was the point of it. That, in my mind, was the point of it. It wasn't talked about that much, but there were people in the pharmaceutical industry, especially in other industries, wanted to bring under control these people, who are the job of determining things, in an honest way as possible. And then they start pouring in money. All of my money, I got generous amounts of funding. Every last cent of it came from the public till, from NIH. So I didn't, and I was able, and I had the academic freedom, and it was all lots of fun, but that's all kind of disappeared. Here is an increase in corporate funding. The two go together, and if not accidental, we could talk about this a lot. But eventually, in 2010, it came up to the Supreme Court. That's what led to the Citizens United decision. It was an attempt, not just from our courts or other places, but it came from the point of view that the industry wanted to control what the public gets to know. And so they own the media now these days. The pharmaceutical companies provide the majority of the funding for messaging on pharmaceuticals and health. That's what it is. The whole thing is. And so they have to say what they have to say. They're paying their bills. And of course, in universities, the tenure went down. Non-tenured positions are now going up. And I really feel really badly for young people going into the universities these days and, really enjoying the journey and the discussions and all that sort of thing that come along with the freedom of speech, if you will. That's basically now disappearing. And so researchers are having to do, work or do research according to who's paying for the research, namely industry. And so we have a drug industry out of hand, totally out of hand. I feel very passionate about this because and so the public is now relying on drugs, and they're dying sooner just so somebody can make money. That's really what it comes down to. I published this in the book Whole. In what was it, 2013? I guess now it's 9 years ago. And it was a New York Times bestseller at the time. So in any case, I've given you a couple of lectures here. This is kind of abbreviated, but I just, sorry for my enthusiasm, but it is, I was enthusiastic about, being able to be involved in this and discussing and learning new things. That's nothing like learning new things and discovering that, what you may have done before, you're all wrong. And that's kind of a challenge, but you have a lot of fun to debate people on these kinds of things. So thank you very much for your attention. Look forward to your questions.
Great. Thank you so much, Colin. That was informative as always. So we're going to begin our Q&A session. Before we do, just like to point out that we can, we just wanted to show you some of your books. And I know you don't have any social media, so I guess they can just look you up online to learn more about you. If you want to get the books, you can go through the bookstore, and which will have you, if you click on any of these books, it'll go through Amazon, but it will get a little bit to support what we're doing here at the Real Truth About Health conference. So with that said, let's go ahead and begin the Q&A. If anyone would like to ask a question to Colin Campbell, they can go ahead and they can raise their hand in Zoom, and assuming we have time, we will get to those questions. So you said a lot of really amazing things, so I'm going to ask you some questions on that. You mentioned statins with regard to cholesterol. Given that cholesterol, based on what you're saying and what I've heard other doctors say, is a benchmark for heart disease and not necessarily the root cause of heart disease. What is the correlation between cholesterol and heart disease?
It's pretty good. I mean, it's pretty impressive. Higher cholesterol levels associated with higher heart disease. And of course, we would assume, therefore, that if we could just control cholesterol, maybe we can reduce heart disease. But as time passed, and this is as it passed in the past, we learned that the real cause of heart disease is something different. The cholesterol in our blood, the level of cholesterol in the blood, is only an indicator of our risk for heart disease. And it's pretty well correlated. The higher cholesterol in blood, higher heart disease. That's an oversimplification, I must advise, because there's other things that cause high cholesterol levels, and there's no harm to be assumed. But just the whole idea of just tackling one tiny, tiny, tiny little bit of the equation, trying to reduce cholesterol, is kind of elementary. It doesn't make much sense.
Right. All right. But the statins, which reduces it, doesn't really necessarily help it because there's so many other factors, which is kind of the thesis of your
Right,
presentation today.
right,
Is that
right.
happening?
There's some studies. Let me add a little bit. There's a lot of studies on the relationship between statins and heart disease, and there's a few that somebody sent me a whole collection of all these studies. A lot of them, essentially no relationship. It's too complicated. At the best that I could find in that list was a 9% decrease in heart disease risk, 9% only. That was the best of the lot, and probably might be influenced by the thing. So reducing cholesterol through statins is when we can just do it like what Dr. Esselstyn has done. Just change the diet. That's simple. Esselstyn and Ornish.
So I believe it was you, and this is many years ago, so I'm not expecting you to remember this per se, but I believe it was you with a conversation on one of our panels with Dr. Kim Williams, and he was saying there was a statistically significant impact with statins.
Right.
Why would he come to that conclusion? Is there any evidence that supports what he's saying?
Well, it was really interesting. And you're referring to something. I'm surprised you remembered it. We were sitting next to each other. And so he
Mhm.
brought with him, he knew my views on that. And he showed me some paper at the table to say, no, this works. They had some evidence that, it might reduce it by 20%. He's an MD, and that's what they teach in medical schools. And he's involved in medical schools. And, they're told the best evidence that's possible, with regards to drugs. That's what my concern about medical schools is. Kim Williams is a great guy, by the way. I must tell you that. On a personal level, I like him. He's a smart guy, but I disagree with him. I mean, the data I had basically shows it just steers us in the wrong direction. I don't think he actually disagrees with me, to be honest about it. He couldn't say it publicly. I'm guessing here on that one, so I have to be careful. But Kim is a good guy.
So, what would be a healthy range of cholesterol that we should be shooting for now? Because we've had a one PhD who spoke, and he had said that there's evidence that people with higher cholesterol actually do better, and that what was also said is that sometimes there are other things going on in the body. So people who are eating a healthy plant-based diet, for example, and actually doing it right, not just plant-based, but whole food plant-based, and still have a higher cholesterol, it may be because their body is producing higher cholesterol because of other things going on, and it may need to produce cholesterol. Is there anything to that?
No, I don't really know of anything. The only qualification I might add to this, to my point of view, his point of view, her point of view, but in any case, it's the fact that, and this is for me personally, it turns out I have pretty high cholesterol levels. When I came to Cornell in 1975, for example, really getting into this, at that time, we all had to take a physical because I was working with a very toxic chemical in the lab at the time. And so I did my physical, the first one I had in my life. My cholesterol level was 259. And that was pretty high. I said, what's going on here? I hadn't really started changing that much yet, but it was on the high side. My dad died of heart disease, all that. So, I'm at so a higher risk. I'm very conscious of it. Of course, then when you got to change their diet, it started coming down. But I could only get it down to about 170, 180, which is good. Which is fairly good. But it's actually still high compared to what some people get down to 150, 140, maybe, something like that. But the word in the trade was that it don't go below 150. maybe you don't go any lower than that, and because suicide rates are higher and colon cancer rates are higher. And so what? Good God, what's going on here? But I wanted to get my cholesterol down. It started coming down when I started eating the right way, and it got down to about 180. And I said, well, I can't get it lower. Our kids are, born, they're eating this way, more or less. They're down to 120 to 110. And then the China study, the average in the rural Chinese was 120, really low. The average, mind you, it was below even the low range in the United States. And so then we compared the United States to China. That's another whole story, but and too long at that. But those of us who do not nurse, tend to have a higher baseline cholesterol level. I did not nurse. For some reason, I guess we were on a dairy farm, and so there was something about the milk that reacted with me. So my mother told me, and so I was given something different. And at that age, critical age, you get left with a little bit of something left over. You can't get cholesterol levels as low as what you might like. So I've been but 170, 180 is okay. But the people who don't nurse have that problem.
So as far as a healthy range, assuming that someone nursed and they don't have that particular issue, and they're eating a whole food plant-based diet, what should they be hoping for? And if they're not hoping, or excuse me, if they're not achieving it, what would be healthy ways beyond just the whole food plant-based diet that they might be able to get into that range that you suggest? For example, red yeast rice, people talk about. Is that an option?
Yeah. The number that, at least for young people, that's just fine is 110, 120, 130 in that territory. We learned that from our work in China, by the way, as I mentioned. And so it's fine. We used to be that was too low, as I said. But no, in my estimation, and I think it's generally accepted now, is that our children who are born and nursed properly and fed the right food and so forth, they're going to remain around 110, 120. Our children, with 5 children, they didn't really get into this completely, except the youngest one maybe, but so they're kind of rather low because they're eating the right kind of food. So let's say I'm going to just throw you want a number. I'm going to say too low is not too low. There is this thing of being too low. 110 is probably as good as you can get. 100, 110, 120, that's all very good. But then on the high side, unless they're not nursed, going up as high as 180, 190, 200 is not so bad. So the normal range is somewhere 100 to 200, let's say. But
Okay.
now the discussion mainly is focused on not total cholesterol, but it's on the low density cholesterol, which is the different fractions of cholesterol. The one that matters the most is the LDL cholesterol. Anyhow, let's say 100 to 200.
Okay, great. Thank you. And based on your research, is there any real correlation between cholesterol level and suicide?
No, I tell that because it was a typical misassumption at the time that I was actually working with the National Academy of Sciences. They were serious people and who were sort of in the field. And they were suggesting that as the result of the level of cholesterol too low. When we got our data in China, no one wanted to believe it. So we had to go back and analyze it 2 more times. And finally, the people in the heart disease arena did start changing their views.
Great, thank you. So you brought up vitamin A and how with regard to lung cancer, and it turned out when people were taking vitamin A, they were actually getting higher rates of cancer versus what they were expecting, lower rates. And that kind of throws into question a lot of the idea of supplementation, right? So so I'm going to break it up into two things. So when people talk about supplementation, there's obviously, there's the vitamin A type of supplementation or very, specific nutrients versus taking something like curcumin, which is more whole food plant-based. If you'd
Right.
agree with that? Um, Are there specific supplements that you would suggest taking? Are there specific ones that you would avoid? I know B12 is a must, is my understanding in especially with people eating a whole food plant-based diet, but the
That's
general
a stretch.
um D is another one that a lot of people in this community are fond of taking. What are your thoughts on supplementation with the nutrient specific supplements as well as things like curcumin or turmeric where you're eating more of the whole, a whole food?
Well, you mentioned two things. Really, one point is very well taken, namely single nutrients is usually what we are accustomed to. And I don't see any need for including B12. Uh, I take a B12 to be honest about because my wife tells me to do it, but that's an overstatement. If you go back and I know the individual who actually promoted that idea, it really is an exaggeration. And but it's harmless in a way because it's water soluble. So if there's any benefit, if there's any effect at all, it's going to be beneficial maybe. So a lot of people take it, but I am not convinced of the data to say that we all have to take it. That's silly. It's just simply not there. On vitamin D, first off, the first point that I would make, vitamin D is not a vitamin. And that the fact that they called it vitamin D means it's important and we should be taking vitamin D and all that sort of stuff. What we need to do is get out in the sunshine. That's the best way to get a vitamin D. It forms in our skin. We don't need to consume it. And there's some difficulty if you get vitamin D. And that incidentally, it's too long to discuss here, but that really got wrapped up with an organization that supported the industry called the Vitamin D Council, trying to advocate, taking vitamin D for this, that, and everything else. No, it's not good. My vitamin D is considered to be too low. The range was on 30 to 60 more or less that we should be at. My levels in blood had been around 20, but I've been out in the sun and everything else it was wrong. My wife is the same way. But now the medical community is coming around to say, oh, that's not so bad. So I've seen a shift in the attitude on even on vitamin D. One of the things about recommended or not being that some of these nutrients being recommended, it is so wrapped up or influenced by, maybe I should say, by the industry. It so often happens that way. And so I don't take drugs. As I say, I'm 90. And when we get older, I will agree, though, that as we get older, our bodies become a little more depleted in the kind of nutrition we may have been accustomed to. And so maybe taking a supplement of even B12 and D, and even though I'm not fond of it, nonetheless, or maybe something else, I don't know. Who am I to say? It's just on the basic theory that we tend to get kind of low as we get older. And maybe we can take a little bit, but I don't take those things.
So you mentioned that there was no real downside to taking B12. So I want to ask you two questions. One is, um, uh, how would we get it in our food? Because my understanding is it's not really prevalent in our food anymore. So the fact, do you believe that we are getting it through a whole food plant-based diet? That's the first question. And then you said that B12 isn't necessarily bad for you, so it's okay to take. Is the same thing true for D?
For D, yeah. Uh, well, as far as the supplements are concerned, we can both the B12 and the D, as I already said. Uh, you know, if they want to take it, okay, go for it. But I don't see the evidence to justify doing that. It really it's just not there. So I tend to, why do it? I just eat the right food. There was a study in Switzerland, not known, on B12 on one occasion that I'm familiar with. It didn't get well publicized, but they were doing some work and found that in certain plants there was a B12-like substance that seemed to do the job in plants. And so the evidence for using B12 came from a kind of a very questionable, highly questionable source initially. It was especially done on a little girl in Africa is supposedly suffered something. So B12 is significant, obviously, but the people in Switzerland found that there was some B12-like activity in plants of all things. So again, I don't get, but there's no hurt. Let's say it that way.
Oh,
If you're taking, especially B12, it's water soluble.
and
And
then
so
D,
take it. But
and then D is that is there any hurt for taking D?
uh, on the high side, there can be some difficulty. But on the usual levels that might be advocated in this country, they're not too high. And you could get your level up from, let's say, 20 or 15, 20, which is always considered too low up. You can get up to 30. Uh, Part of that story broke out in the news some years ago. The guy that was advocating that kind of change was associated with the Vitamin D Council.
Okay. And all right, so to go back to your thesis about whole foods being better than taking individual nutrients, what like obviously within the whole foods plant-based world, there are people who say different things. I don't know what his stance is on this currently, but I know that your friend Dr. Caldwell Esselstyn for a while was against taking nuts and seeds. I don't know where he's at. So there's the fat stuff, and then you have someone like Brian Clement who says don't eat fruit. The World Health Organization says that a lack of fruit is the number one indicator for poor health in the world. So there's a lot of confusion with that. What are your thoughts on which parts of the whole food plant-based diet are essential? Should people try to eat a little bit of everything? What do you think?
Yeah, eating a variety of, first and foremost, eating a variety of plant foods. That includes fruits, vegetables, grains, if you will. Also some nuts. I don't want to talk about my friend Esselstyn in a sense, but he and I have talked about this privately and stuff like this. And I was on a panel with him publicly a couple of years ago, and we were both asked, "Hey, one of you guys say this, and the other says that. Well, why don't you?" So we had a public discussion. And what he said at that time was that he didn't want to go and say to eat nuts because they have nuts in their car in their car in the glove compartment. They got here and there, and they take license to use all they want. Well, he eats walnuts for starters,
Mm.
and so I mean, he's a physician, right? He's making recommendations. And so he wants to be kind of on the safe side, as physicians do. And so there's some difficulty maybe with taking too many, but I don't know those difficulties, to be honest about it. So we eat all the nuts we want. Uh, yeah, but he's backed off from what he once said, I would suggest. But he can't do too much of that shifting because, if he said this before and then turned or shifted, it changed later. I don't know. Physicians seem to be that way. They don't want to they don't want to change. But
So now, what about something in the diet like salt? Should we be concerned with our salt intake? Are there certain
yeah,
salts better than other salts? As a whole, there's sea salt versus table salt. What are your thoughts on the subject of salt?
yeah. Again, the one who's probably the most extreme and taking no salt is Dr. Goldhammer. Again, another very good friend of mine. He has a fasting clinic, and I've been there 2 or 3 times. He's a great guy, and he goes he kind of goes to the extreme in a way, but I think he doesn't mind my saying this, and that is that we had some private conversations, and once again, when you're fasting, there's no point of taking salt just because it's important. And so he doesn't see any evidence in favor of taking salt. And he was asking me, he says, did I have any evidence that we should be taking more than 1,000 milligrams or let's say 1,500 a day? And I can't think of any evidence that we do not need extra, but at the same time, going to the extreme and say no salt, that's too much for me. I've told that to Ellen, because it makes food less tasty.
Mhm.
And so, a little bit of salt, and if you're going to use salt, maybe sea salt is better than the otherwise. It's a potassium chloride, not the sodium chloride. And and I'm kind of relating our private conversations that, I say we can use salt and flavor things a little bit. We can't make it so bland that people aren't going to want to eat it. So, but use it at the table. They usually don't use it during cooking. And if we go above 1,000, 1,500, that's probably okay. He's more down in the territory, 500, 600. And he's fascinating. He doesn't want them to use salt at that point in time. So we have somewhat of a different, not much difference in opinion, actually.
And does the okay, so potassium chloride though you think is a better alternative than
Yes,
sodium chloride?
that's probably better. And you don't notice what I'm saying here. You're asking questions. I'm saying things. Black and white answers don't really exist very well in science. You know,
Okay.
there's not definite number here, definite number there. That sort of thing. So we have to be, mindful of what we're eating, obviously. But
Of course. And so now when people are eating a whole food plant-based diet, and correct me if I'm wrong, you're the person who coined the term whole food plant-based, is that correct?
yes, I was on a committee that determines who gets funding. It was a committee of the National Institutes of Health. And I was getting all of our funding, all of our funding, a lot of it came from, and I was very active in determining who else got money, from other people. And one day there were about 12, 13 of us on the committee or something like this. We're the ones who make the decision on who gets funding and who doesn't. And so at that time, they're all, cancer researchers, oncologists and cancer researchers, and that was my territory at the time. And we started getting a couple of applications of people wanting to study a little bit about nutrition. So my colleagues, all oncologists and geneticists and so forth, they asked me, said, could you come and explain to us what your view of nutrition is? So I had to think about it a bit, as if I couldn't explain it in one hour session. And that's at that time I didn't want to use the word vegetarian, because the vegetarian word to me is a bit of a mischief. It's not accurate. The scientific basis for vegetarianism has not been good. It's been rather poor, primarily with the standpoint of cholesterol and fat and stuff like that. So I didn't know the word vegan at that time. This was in 1978, 79, quite a long time ago. And so I gave my little spiel, and I had to think of a word and something, and I said, let's call it plant-based. And then about 3 or 4 years later, I was the principal consultant of the Federal Trade Commission on vitamin supplements, and I was getting into this concept of wholeness. So I used the word whole at that time. So between 1970, 77, 78, and then 1982, 83, I put the two words together, whole food plant-based diet. It didn't go anyplace much. I published a bit of it, but it didn't take off. God, didn't take off until after we wrote the China study. We said it there. My son and I said whole food plant-based diet, and then it started getting a little bit of attention. But I don't like the words. Sorry about those people who sort of espoused to this. I didn't come down that road, and I actually think that the use of the word vegetarian veganism has not been, quite frankly, that good. It's not very good science to start with, and it doesn't sell all that well. And I have to tell you, without giving the name, an individual really big in the community of the vegetarian vegan community, not PCR, but someone else, called me up one day out of the clear blue and asked me after China study came out. He said, "Whatever you're doing," he says, "you're doing more to cause change than all of us put together in the vegan vegetarian communities." I took that as a compliment, of course. And so I don't, because he's very sensitive to, in his business, doing what he does. But I got some encouragement, to say the least, that the
Well,
whole
I definitely think, not eating animals for animals' sake is obviously, I'm personally vegan, but I consider myself vegan and whole food plant-based, and I see them as two separate things that have overlapping, but don't necessarily need to overlap. So you could be vegan without eating anything healthy, and you can be
right,
whole
right.
plant-based and not really care about the animals and do things that are not necessarily good for the animals.
Right.
They're
Right.
really very separate things. So now in the community of in the whole food plant-based community, there is an arrogance to some extent of, oh, I'm shielded from everything, right?
Right.
What is, which is
Oh,
clearly not true. So how often do you find that people who are eating and properly so a whole food plant-based diet still end up with something like cancer or other diseases?
good question. I mean, obviously, if you look at the data, your population data, especially, as I was showing in those charts and stuff like that, the lowest rates tend to be obviously those people who are eating, on that end of the scale, eating plant-based diets. Then you're looking at the mechanistic studies and the laboratory study, and of course, what I saw over the years was just pretty emphatic almost, I should say. But at the same time, I to get to your question. Again, without being hard and fast on these things, the best evidence that we have, if you do a whole food plant-based and you do it well, your risk of getting, uh, let's say, those different diseases only like on average 10% at the most of what the high areas are. And the United States is always high. So if you can reduce your risk by 90%, that means, occasional some people even doing the right thing are going to, get the bad result. I mean, that happens. That's the way it is. It's not black and white. But the evidence is so overwhelming. If I can reduce my risks by 90%, that's pretty good for all the disease at the same time. So that is the formula basically for a whole food based diet.
With the implication of the fact that 10% of the people still get the disease, even though they're eating this wonderful diet, um, would the implication be that it's genetic, the one like, of the diseases they get?
Partly that may be true. Angelina Jolie, I think we talked about that before. Certain genes occasionally pop up to give higher risk for certain kind of diseases, and those people are more sensitive to doing the wrong thing, so they're going to, have a higher risk for getting those diseases. But at the same time, they also can reduce the risk to next to nothing. But they have to really stick to it. They have to work at it. They have to stay there. Don't stray. So the genes do play some role. That's inarguable. We can have some family traits and certain things, but it's so minor, and there's such an exception compared to the average population. And so I can't say that. And in our study, the one thing that really got me going on this whole thing early in my career was in our animal studies, quite frankly, when they start out with a gene predisposition, a genetic predisposition for getting cancer, all of them. But we could turn it off completely by nutritional means. I mean, that was pretty dramatic.
Hmm.
And so, nutrition is controlling gene expression. The alternative expression is genetic determinism. Okay. And actually the cancer industry who's making chemotherapy, stuff like that, they rely on this concept of genetic determinism. They don't say it out loud very much, but they sure do say it. Let me tell you, the National Cancer Institute had that in the first line. Cancer is a genetic disease. I called attention to that. They took it down. I don't know whether they did that because I had done that or not, because I am fairly visible in that community. But in any case, uh, genetic determinants have been vastly overrated because it's if you go around telling people, hey, we're all going to get disease one kind or another. If they say something like this, what are you worried about? If you got the genes, you're going to get the disease. That's silly. But they've argued, the industry will argue that these diseases are genetically determined when it's not. They go to the other extreme and say, don't worry about it. If you're going to get a disease, you're going to get it. And those are very few and far between.
Thank you. So, there's an idea, and you can correct me if this isn't accurate. Like with people who smoke cigarettes, for example, if they quit smoking cigarettes within 7 years, they'll have the same health outcomes of somebody who's never smoked. And I don't know the veracity of that, but conceptually, is there, people oftentimes think they're broken after being unhealthy for a long period of time. With a whole food plant-based diet, over how long does it usually take for someone to have that vibrant health? And will they have the same health outcomes as somebody who didn't do all that kind of damage themselves throughout their life after a while?
That's a great question. That's a very germane question. I had to face it myself. My wife did too. I mean, as I said, I was in my early 50s and eating all the wrong food. And so changing at that time for me was a bit of a challenge, but I was being convinced of our data. And my dad had died at 70. He was otherwise a farmer and good and fit, and his brother at 58 of heart disease. And their father, my grandfather, was 73. So it was in my family, my wife's family. Her mother passed at 51 from colon cancer, and then she lost two brothers in their 50s. So we had family issues to think about. So that encouraged us to take more seriously what we were doing. And but I was in, as I say, my early 50s when I changed. I thought maybe looking back, I thought it was a little bit late making change. It turns out it's not at all. It's it's you can change at 60, 70, I think, 80, you can get some benefit out of it. And so, and we, both of us, my wife and I, I'm speaking strictly in a number, N of two, only two of us. But
Mm-hmm.
in reality now, I said I'm 90, she's 83, and I don't take drugs, and should knock on wood, as I say. I mean, it's a crazy thing for me to say. And we're only two, doesn't prove a point whatsoever. But that's what we tend to see.
So as you may know, you're extremely revered in this community, and then there are a lot of doctors out there, especially medical doctors, who have their own spin on whole food plant based. So I think people would love to hear but it's also very confusing for lay people who
Right,
aren't
right.
nutritional biochemists, right? I have to admit
Sure.
I'm not a biochemist. So and I think the audience would love to hear if there are specific doctors out there or dietitians that you think are more spot on than others that we should be listening to more so than others. And if there are any doctors out there that you think maybe are with all, assuming that their, integrity is intact, are not necessarily leading people in the right direction. If there's any doctors that we should avoid, I don't know if you're comfortable answering a question like that, but if there's any doctors, I'm sure you're fond of Dr. Esselstyn's work. Are there any other doctors out there that you would recommend people listen to?
Well, Dr. Dean Ornish, by the way, in fact, he had, I took his advice seriously. He was on the cover of Time magazine with his comments about heart disease, actually before Esselstyn. And I got to know Dean, and the publisher took his name and featured our books with his recommendation for the books throughout. So I owe him quite a bit. He didn't stay in the community quite the way that Esselstyn did. Esselstyn came along, and he about the same time, more or less, but he did his study. They're both of them, Ornish and Esselstyn, were doing their studies early on. They were both calling it low fat. They didn't go to the area of protein; they just low fat, and they were both using dairy because it was so important. You couldn't do without that. And I told him, I said, if I were you, I would stop the dairy. Well, Esselstyn did stop, but Orange did not completely change. And so, and we've had this really personal, very close personal relationship, and Esselstyn's stuff got published and everything got recognized. He's a great guy. But one of the reasons I like him is not because of his understanding of nutrition and that sort of stuff. He's just a first class individual, a
Mhm.
very honorable person. And that's, I mean, Orange is too. But in terms of and naming others, and I'm actually just now finishing up a book on that point. I have become, I have to admit it, become very upset with the medical system. I've been close to it. I've spoken in medical schools and their conferences in more than 40 states in the United States. And I was actually a representative of the AMA for a little while, even though I have a PhD, not an MD. So I really got to know the medical community really extensively. And the same thing going abroad and speaking abroad at the same time. And I came to the realization that the medical system is pretty much a so-called reductionist system.
Mm.
They want to fix things, but one nutrient at a time because it sells. And why do they want to sell that? Why, how can they sell it? It's because they get a patent on it. That's the way the business world works. They can't take a chemical out of nature and then use it as a drug. They can't do that. They can't make claims because you can't get a patent on it. They can't protect their business. So what they do when they can't take the chemical in nature that somebody might see it looks like it's a good thing, and they want to use it, they create a derivative of it. And the moment they make a derivative, that's not natural. And at that particular point in time, all bets are off. That's why all drugs have side effects. And so, anyhow, I went down the wrong tour. You were asking me. So, what you asked me is
I
first.
was asking you doctors that you recommend.
Oh, yeah. Uh, well, the ones that I've met a lot who now are kind of getting into the plant-based community a lot. I was had a class at Cornell, and I actually offered a course called Vegetarian Nutrition. I didn't particularly care for the title, but university wanted me to do that to get students. But I got some funding to bring in a total of 32 guest speakers over a period of 6 years to my class. And so I reached out and got a whole bunch of people. Six of them were avowed vegetarians. And I brought them there. It didn't turn out so well, to be honest about it. And they were all MDs, the ones in this case. One of them came in, gave a lecture, was excited about it and stuff like that. But then he went back and he organized his study and put my name on his paper as a lead one. And it was the stuff in the study really wasn't there at all. He didn't even do it quite like that. And so it created a very unpleasant situation. I told him to take it, withdraw it from the journal, and he wouldn't do it. And another one, so he got into the vitamin stuff,
Mhm.
selling vitamins. And then another one was there, I had him twice actually. He got very active and he was making the argument entirely on ethical reasons. And I worked closely and I was on his board and everything like that. But that to me, the ethical reasons alone, then he goes down and takes he doesn't, none of them have any training in nutrition, none. So, but he starts making nutritional arguments that are not correct. And it's hard. It's hard to deal with that sort of thing. I mean, saying things like, for example, the cause of heart disease is saturated fat. And therefore, just get rid of saturated fat and it was end of story kind of thing. Or work hard to bring under control the consumption of cholesterol, which is okay for ethical reasons, I guess, or scientific reasons, but it's not the real reason. So that creates a problem. And then of those four, they all went off and did their own thing, not surprisingly. One of them wanted to get a lot of facts together. And this is the facts, all kind of isolated. That's not the way science is. That's not the way nutrition is. And none of them are trained in nutrition. None, because they don't teach nutrition in medical school. So I do have some pretty serious problems with the whole medical system, to be honest about it. And I know there's a lot of good people working hard and trying to do their things. But at the same time, I also have friends in the medical community too that are, they are anxious to learn what they can learn about deserved nutrition. And it's a very different philosophically. That's the issue. They're working on an idea of one thing causing or creating a disease, and that's their game plan. And it's just they're told what to say. I can tell you this, and this I don't need to worry about naming names, but we moved to a new area about 3 or 4 years ago. So we wanted to have a personal physician. And so I got a personal physician, a younger guy, nice guy. That wasn't the issue. And I had some blood pressure problems that creeping up on me, getting too high. And I said, geez, and he told me, of course, to take the blood pressure medicine, the lowest dose of this drug called amlodipine. And so I took it for 6 days and I quit. I said, I don't need that thing. And anyhow, when I went back in later, he says, "What are you taking? Are you taking your blood pressure?" I said, "No." He said, "Why not?" And I told him, I said, you guys in medicine, you advocate that because of a meta-analysis of 26 studies. 26 studies shows that those blood pressure medicines do not decrease stroke, as you say they do. That was the conclusion of that study. Yes, it reduces blood pressure, but doesn't mean it reduces stroke. And so he said, "Well, really? Well, let's look at and he went to their Bible on the internet. He said, let's look at this," because he didn't believe me. He said, "Let's look at this." So we started reading down, the justification that all the doctors have, and they all have to, advocate this. And we started reading down, and I said to him, I said, "Do you see any evidence?" We're reading together. I said, "Do you see any evidence here that claims that it's reducing stroke?" He finally said, "Well," he said, "we're told to say that." I said, "I know you are."
You're probably doctor's worst nightmare as far as,
Yeah, I mean,
disagreement.
when I come in there, he doesn't, I don't know, he's kind of cautious, but he's a nice guy. I want to say that.
So there's a doctor that I want to ask you about that is very big in this community that a lot of people reference, even during these presentations. His name has come up many times, which is Dr. Michael Greger. Are you familiar with his work, Nutrition
Oh,
Facts?
yes, very much so.
What are your thoughts on his body of work? And then I also want to ask you, as part of that question, we have another speaker, John Abramson, who talks about how the pharmaceutical industry has captured the American healthcare, and specifically the medical journals and the peer-reviewed medical journals. And he points out that this peer review process most often only gives the study design and the conclusion to the reviewers, not the underlying data points. So what are your thoughts on that? And then how that relates to what Michael Greger does, which is to review all the peer-reviewed medical literature?
Well, I know both of them. I know Greger quite a bit better. I had him at Cornell too. He did his undergraduate work there, actually. In the early days, actually, I'm not happy with his approach because he has not worked in the field, and to my knowledge, he's not had any training in nutrition. He's never participated in a profession, of actually doing research. To my knowledge, I've never known of him to publish a single paper. I've had no more than 300. So he comes along and sort of pretends that he's this nutrition guru or something like that. He's not studied it. He hasn't worked in the area. Doesn't publish. I mean, those are critical. That's step one to even to be in the trade like this. And so, but nonetheless, he does rely on a concept that actually is the antithesis of what I talk about. I have to be honest about it. I'm being public about it. That is to say, he collects a lot of individual observations. He calls them nutrition facts. And then each one has a certain dimension, a certain effect, if you will. But none of that. He's not worked on any of those kinds of things. He reads it in the literature, sort of finds the things that he wants to find. And the most serious part of that is that the assumptions made that they're all separate items. They're all separate items. And you can do this and this. That's a source. That is the source of confusion. In public at large, in a larger context. Public tend to think this is good, this is not good. Have this much. I mean, they get into those kind of details. That's what doctors are trained to do. And that's the way it exists. And as I say, I was a representative of the AMA at the times, and I've certainly been in the medical system a lot. Trying to argue or make a presentation that nutrition is a very different concept fundamentally. It's not a lot of individual facts. It just simply isn't. That is a source of enormous confusion. And it will never go away. You can't conquer. You can't make advances by doing that. One thing he does is really good in the sense that these little videos and stuff like that. People like bite-sized information, and they take it with a great deal of certainty. If they hear someone presenting it, and so it's kind of clever. People like that kind of presentation, and that's a plus. But in terms of just taking out a whole collection of all kinds of stuff that you just read out of the literature, my God, I can put that kind of thing very easily together and make a case and choose my topics, my sources, and prove, if you will, that animal food is the best thing that we got going. So then it becomes the choice of the person putting that stuff together to what they say works and what doesn't work. When in science, we don't do that. We just not or try not to do it.
Great. Thank you. So we've got about 7 minutes or so left. So I'm going to give the audience an opportunity to just ask a couple of quick questions of you. So Joe W., please state where you're from and briefly ask your question.
Dr. Esselstyn, the Flexner report is historically referred to that Rockefeller medicine basically got rid of alternative health way back in the early 1900s and was the purpose for or the source for drugs. Is that something that you've discussed with medical professionals and your colleagues, the impact of the Flexner report?
I know the Flexner report. I really got into the history because of the confusion that existed at the time for me. I spent a year at Oxford University and actually got back into the history of medicine quite thoroughly, all the way back into the 1800s, even late 1700s. The Flexner report was key. You're quite right. It was very significant. But it was a structure, if you will, a structured way of thinking about health and medicine in terms of one thing at a time. As I've mentioned several times, it's one cause, one mechanism by which it works, one disease outcome. And that's it. That's a business model. That's a business model because it gives an opportunity. In fact, it requires, in many cases, it requires something to be patented. That is a business of business. So medicine as a practice became a business primarily. And I have strong opinions about that. I wrote quite a paper on that at the time, the history of this field. And that's when so-called vitamins were discovered, not really vitamins. And it led to this whole notion that I now these days call reductionism. So the Flexner report was very instrumental. You're absolutely right, and very significant and honored, by a lot of people. But I don't agree with it in principle, especially because it was English at the time. They were very much involved in this at Oxford University, where I was, and I met some folks that we talked about that back and forth, and don't care for it.
So there's a lot of stuff online about the history of medicine, and like the Rockefellers taking over and blocking all of the other, blocking all the other modalities of health. Is in your study of the history of medicine, is that something true? It sounds very conspiratorial, but a lot of things that sound overwhelmingly conspiratorial turn out to be factually correct. What's your thoughts on that?
Yeah, there's a lot of effort made behind the scenes to shape public opinion to start with. And so the idea of focusing on one thing at a time, and especially if it's patented, that becomes a big thing. That's why they control the media. And so it becomes a discipline unto itself. And they don't want to hear anything like what I say, like all the nutrients working together as food, because people can do that for themselves. They don't need to buy all the drugs, and they can live longer. They can get the benefit. And so I would argue that even going back to the Flexner report, or covering what you just said, that there's just focus on one thing at a time. It's been really a serious nemesis in this whole arena of human health, and a much more natural. I like to use the word Mother Nature, because nature, once you get to understand, how these things happen in nature the way they do, infinitely complex. Not the human mind can't comprehend those things and all that comprehensive, but there's certain ways to kind of get a survey of all of it. That's where the business is, and so uh, I'm kind of having a difficult time with really understanding what the medical system really did, why they did it. They started this way back in the middle 1800s. It came at about the time of all things. It turns out I was reading one book there in 1843, I think it was. This gentleman was a physician, a surgeon, fairly well known, and anyhow, he talked about the nature of, it's called constitutional nature of disease. Constitutional nature of disease, which I was kind of coming into my mind too. That's wholeness. That's the word that's the word whole. And I read that book in the Oxford Library, and I was just stunned by it almost. I felt like, I felt almost it was my book in a sense. And I told my wife about it, and I said, this book, and then I looked back to see who the author was. And his name was George McElwain. My father's middle name is McElwain. He is my great-grandfather. I didn't know it. Although ancestry, I've gotten involved in ancestry, and they can't prove it. It's either George McElwain or his brother. In fact, I will show you. That's on the screen.
So just to be clear, so you did a body of work that you had your own trajectory. There was no family lineage of this. Quite to the contrary, you were basically all about animal protein growing up.
Right.
And then you find out that you basically replicated your own great-grandfather's work.
Right there. He had 14 books. This is the book, one of the books. And then this is my grandmother's father. And that's what the family, they can't absolutely, ancestry can't exactly prove it. It's either her father or her uncle. So we're not sure of that. But it turned out that my father, when I was young, I went and told my mother. She said, "Can't you remember your father always talking about him?" Well, I didn't remember. So for me, it was totally accidental. My father was an immigrant from Northern Ireland. And so we learned about this from talking to his cousins.
Wow.
My father only had about 2 years of elementary school education when he came here. That's all he had. And so that's part of my story. He actually found out a way for me to go to a high school. I had to drive 102 miles a day, not to go to the rural country high school, but one in Washington, D.C. And I did that for 5 years. So he really had a fantastic influence on me, and he just wanted me to get the education he didn't have. And it turns out his middle name is McElwain. And our youngest son, who wrote the China study with me, is named after my father, McElwain, and this is George McElwain.
Wow. Well, that concludes our time. So thank you so much. Always extremely enlightening. So I really appreciate the presentation, as well as all of your candid answers. So if we could unmute the audience so they can share their appreciation.
Thank you. Thank you so much. Thank you.
I hate when they do this.
Thank you.